The master station, or maybe master controller if you like, would be kind of the central brain of the whole thing. It would have a touchscreen interface and display all the data that we might want to gather, maybe have some user settings and that type of thing. And it would connect to the outside station, the inside station. The outside station would be a weather information gatherer. We decided to have an anemometer. We also wanted to have a temperature sensor though, so we could see if it was hot or cold. And someday we'll probably put a precipitation sensor and humidity sensor and all kinds of cool things. The inside station, we decided to simulate what might be a heating system and an air conditioner in a house. This is the master control station. The concept here is to have a home controller and weather information station all in one. And it's a self-contained mini controller that runs the .NET Micro Framework. On the screen we have several pieces of information. At the top of the screen we have these little buttons that let you switch the different modes. The panel over here is the inside panel and has the current temperature like you might see on a home thermostat. The next panel is our outside station. It gathers the information from the outside station and displays it here. Over here we have the information actually gathered from the internet, real time. The three stations that we have, the master station, the outside station, and the inside station, all communicate over Ethernet. They use one of the really exciting technologies that exists in the .NET Micro Framework, which is the Devices Protocol for Web Services. This is a standards-based protocol that Microsoft's involved in with several other companies. And it's based on the general web services type concept. But it's specific for devices. Writing straight C code, you got to write everything yourself. Don't have any OS services available to you. When I looked at the .NET Micro Framework, I saw a lot of these pieces just built in. That made it really exciting. I had GUI components that I could just call into. Writing drivers for things like the serial bus or I2C or even the GPIO usually takes just a couple lines of code. There are also things like threads, XML parsing, network support, TCP/IP stacks. All of this stuff is just built right in. One of the great frustrations in embedded development is it really can be difficult to find a good tool chain. And even when you find a tool chain that compiles well and creates great code, a lot of times the IDE and the debugger and the interfaces are just a challenge to use. Finally, the .NET Micro Framework and C# and particularly Visual Studio bring a world-class development environment to embedded development. What's that mean? It means you get a lot more done a lot quicker. This project, with all of its networking, connecting to the internet, the devices protocol, the drivers for the temperature sensors, the anemometer, everything took me about 70 hours. The last project I did that was even close to this, using other types of systems, took months and months of work.